Alright, welcome back. In this, we're going to go over how to identify hybridization in seconds. The reason I'm going over this, actually, first, before we do that, I made a grand total of $0 in the past 28 days. Alright, I'm done with that. Okay, so the reason we're going over this is because in general chemistry, you learned about hybridization. Now, you're supposed to stop there, but organic chemistry has now incorporated hybridization. Your professors may ask you on tests or in lecture, what is the hybridization of, I don't know, like this carbon? And you're supposed to give your answer. And usually students will say, I don't know, right? But don't say that, okay? I'm going to show you how to identify it in seconds. Is it Sp2 hybridized? Is it Sp3 hybridized? Is it just, whatever hybridization? I'll tell you how to do it. It's so easy. In seconds, you'll learn it. So hybridization is basically just a way an atom takes up shape in our universe. That's what it is. Hybridization is like a huge word, fancy word. It's that easy. It's just, what does the atom look like? So you may hear this atom's Sp2 hybridized or Sp3 hybridized. But how can we tell? And this shouldn't be came, it should be... Oh, I'm not going to re-record this. Okay. Here's the cheat code. All you need to do is look at the number of atoms attached to your atom of interest. For example, if your professor on a test asks you, what is the hybridization of this carbon right here? Okay? What you need to do is look at all the atoms attached to that carbon. And that's how you're going to get your answer. So, if there are 4 atoms attached to your atom of interest, whatever your professor asks you, it's going to be Sp3. That's it. That easy. If it's 3 atoms attached, it's Sp2. If it's 2 atoms attached, it's just Sp. There, done. We're done. That easy. However, there's some stuff you need to know. Lone pairs count as 1 atom. So if your atom of interest, just pretend, is, this carbon right here, and it had lone pairs. This counts as another atom. Okay, so in other words, say if your atom of interest has 3 atoms attached to it and it has a lone pair, it's not Sp2, it's Sp3. You just add, if you see a lone pair, just add 1 to the count. Okay? Now, what you also need to make sure is do not count the number of bonds. If you count the number of bonds, you will get the problem wrong. For example, this. You see that if your professor asks, what is the hybridization of this carbon? And you count the number of bonds. Okay, you see there's a triple bond here and there's a sigma bond here, a single bond. So there's 4 bonds in total. And you're like, you use the cheat sheet, right? You're like, okay, Sp3. You would get it wrong. This is not Sp3 hybridized. This is Sp hybridized. That's why you need to count the number of atoms. That's the trick. See, now you count the number of atoms, you see the carbon has a nitrogen bonded to it and an R group, and that's it, right? So 2 atoms attached, it's Sp. That's how easy it is. There is one exception to this rule. If your atom of interest participates in resonance of any kind, it is automatically Sp2 by default. Even if it has 4 atoms attached to it, it's Sp2. It's not Sp3. That is the exception. Let's go with the geometry now. If you have 4 atoms attached, then therefore it is Sp3. If it's not participating in resonance. If it's Sp3, it's a tetrahedral geometry. In other words, it looks 3D to us. And every bond is 109.5 degrees from each other. I don't know how they figured this out. I'm not that smart, but geniuses, right? If your atom is Sp2, it's trigonal planar. Trigonal planar is not 3D. Trigonal planar, imagine you get a tripod, you take a hydraulic press, and smash it to smithereens. So it looks flat. It looks like a flat triangle. That's what trigonal planar is. And every bond is 120 degrees from each other. In Sp hybridized, it's linear, also known as a straight line. It looks flat to us, just flat, with no dimensions at all to it. Doesn't look triangle, does not a square, just flat. That's what linear means, Sp hybridized. And it's 180 degrees away from each other. Every bond is 180 degrees from each other. Alright, let's do a practice problem. How many sp2 carbons are in this molecule? This molecule is called imidapryl. This is an angiotensin converting enzyme inhibitor, or ACE inhibitor. This helps treat high blood pressure. If you're interested in renin-angiotensin aldosterone, look at my physiology video on it, on my physiology playlist. It's really good. Okay, imidazole. How many sp2 carbons are there? This would be a test question, by the way. This is exactly something you would see on a test. And how do I know this? Because one of my viewers sent this molecule to me and asked me, how do you solve this? And it was a test question. So that's how I know. Okay, there are two ways of doing it. There's the hard way and the easy way. The hard way is just drawing out every single hydrogen on this molecule, right? And like, okay, doing that. But here's a trick. If you know the tricks, it's easy. If you see a double bond anywhere, that a carbon involved in a double bond, most likely it's sp2. Especially if it's in a benzene ring for example, like this. Remember, this carbon has one atom, two atoms, and a third atom. So by definition, 3 atoms, it's sp2. It also participates in resonance, right? Benzene rings do participate in resonance. Right? It's a conjugated system. And since resonance is always sp2, there we go. That's the trick. So this. All these carbons are sp2. There are 10 in total, by the way. This is also sp2. And if you don't believe me, we have one atom here, another one here, another one here. That's 3 atoms. 3 atoms is sp2. And there's no hydrogens attached to this carbon because carbon already has 4 bonds, right? 1, 2, 3, 4. Right? If you were to count the number of bonds, you would see, okay, it's sp3. But do not count the number of bonds. That's how you can get this wrong. If you count the number of bonds and you look at the cheat sheet and you ignore this and you just think about it as bonds and you think sp3, you will get it wrong. That's why. This is the same thing as this, except the oxygen is a nitrogen here, so it's the same thing. This is also sp2, because once again, this carbon has 1 atom, 2 atoms, 3 atoms bonded to it. And there's also this one. So we have 1, 2, 3, 4, 6. So that's 10. That's all the sp2 carbons. Question. Why is this not sp2? This is not sp2 because it has, this carbon right here is 1 atom bonded, a 2nd atom bonded, a 3rd atom bonded, and a 4th one, right? There's an invisible hydrogen here, right, on the wedge. So that would be 4. That means it's sp3 hybridized. And it does not participate in resonance, so it is sp3. Alright, if you found this video helpful, please like and subscribe. Until next time, later.